Rafa, we are here today looking at the new servo drives from Siemens. I want to ask you about the digital drivetrain. I am familiar with the drivetrain, but we would like to learn more about the digital part and what is possible with the drives today.
Yeah, it's a full mouth, isn't it? Yeah, digital drivetrain.
Yeah.
We like to think of it as enablers for our drivetrain. And when we say drivetrain, we're talking about the motors, the drives, the connected loads. So think of them as true enablers for the digital enterprise. And we have solutions for both the design phase when we are into the virtual world and solutions when the machine is already deployed, installed, where we want to try to get data out of the devices. And that's the machine health, as we say. Yeah. So 2 buckets of products, we can talk more about it, but that's in a nutshell. It's enablers to go around the core business, which is our drives and motors portfolio.
So I guess as a follow-up, right, and as you've mentioned, I think simulation is becoming an increasingly important component of, I want to say, industrial automation and engineering in general. So maybe could you give us some examples or some use cases of how you can make that now better than it used to be?
A couple things that come to mind, or 3, if I may. One would be product sizing and selection, right? So we have had tools to aid customers in sizing their drivetrain for quite some time, where they can input their load conditions, their mechanical load conditions, and then our software will suggest an ideal motor with an ideal drive that would fulfill those loads, those speed profiles, position profiles. That's not quite some new for us, but we have that solution for a few years now, some years I should say. What's new is really simulation, and simulation here, it's really handshaking data from the PLC and handshaking data from the actual physical model that you want to simulate. In the past, we had dumb drives per se, where they didn't fully represent all the control loops that are inside of a real drive, a real firmware inside of a real drive. Now we have a block of code, a piece of data block called DriveSim. Okay. And we can it's a true representation of the real firmware of the drive. So we can, with a high fidelity, mimic what would be my position control, my torque control, my speed control into a simulated environment. And when we tie the PLC program and tie a simulation model from your mechanical device, let's say your conveyor belt or your what we have back here, maybe a robot arm. I see a lot of robot arm in automation. Once we tie those 3 layers and we do a time synchronization, so those cycles are being controlled in a precise cycle time, that when you have a true validation of your real model. Okay.
Interesting. And what is the customer feedback been? We've talked a lot about simulation, everything from Siemens Process Sim to NX. And I'll tell you what I tell everyone, Rafa. I love the concept of simulation. When we talk about digital drivetrain, I can now see how more groups would be able to go ahead and use that outside of just kind of the largest automotive companies. But what has the feedback been like from customers about digital drivetrain?
It's any new technology, there's some time for people to adapt and truly grasp what they can all do. But it's our job to really try to break it down into use cases, to application scenarios, and try to show the value really that we bring to the table. The customers that we've been talking to, they understand the complexity of integrating those 3 layers, the automation, the drivetrain, and the mechanical layer. The initial stages is kind of being skeptical. Okay. Right? Can you truly mimic what a real machine will do? And we oftentimes say, yes, if you think about it, it's exactly the same piece of code that will be downloaded to the devices afterwards. Yeah. So we can validate those models in the machine. And more often than not, once they adapt, once they implement and feedback us some of the results they achieved, they see very small percentages being off from the virtual and the real machines. So the feedback we get once we pass that barrier, once they pass that initial kind of being skeptical to change, they see the value, they understand the value, and they see how it truly enhances their efficiency level, both from a design phase as well as when they are in operation.
And I will say, if I may, to add that from like the end customer standpoint, I think that until you get that education maybe and better understanding of what's possible, you think that you need a much more advanced model than what is usually created, right? So I think you have maybe higher expectations. You expect it to be like a complete physics engine, and it is possible, right? I think it's obviously time and effort, but at the end of the day, you need to be able to get close enough to your application so that you solve a true engineering problem. And I think that's what you guys are able to provide, right? I think that's what's critical for the customer.
Very much so. Yeah.
And if I may, I feel like kind of looking at it as a whole could be a little overwhelming. One of the things that we have behind us is vibration sensing and the abilities to go ahead and kind of dig deep into that. Can you take us through what we're seeing right here behind us?
Yeah, for sure. Assuming that now we're into the real world, we have simulated, we have virtually commissioned, validated all the models. How can we get more data out of the connected machines that are in the field? This is condition monitoring solutions. So we have a couple of different flavors. These guys here specifically focused on doing vibration analysis, but you can also bring any analog signal to the devices as well. So you can measure temperature, you can measure pressure, flow, any analog value really.
Absolutely.
These are tool bags for any vibration analysts when they are trying to do machine assessments. You can either have a simple, we call diagnostics, where it's, if I may do an analogy, like an engine traffic light, where it's going to tell that you have a problem, you have a trending issue over time, and you need to send your maintenance team to check what's going on. Or doing that same analogy on your car when you plug the ODB connector on the computer and it spills out your problems specifically. That's the type of analysis we try to do with this product too. Then it gives you precise mechanical signatures of those most common vibration faults that you may see in the field, unbalances, misalignments, pairing issues. A vibration specialist with a trained eye, with the knowledge of looking at those signals, they would know now, they can answer the question, what happened or what might be leading to a potential failure. You probably have a loose torque on one of your motor mountings or bolts. Go there and retorque it. Or the bearing on your drive end motor is going bad.
Yes.
Do a root cause analysis and be prepared for maybe 6 months down the road to do a planned shutdown maintenance service on the machine.
Yeah, and I think that's extremely important, right? And I don't want to assume that all of our listeners necessarily understand drivetrains to the level that we're discussing here, but in a practical sense, right? I think the takeaway here is if you have an issue in the drivetrain, it could be for a number of reasons, as you mentioned, and ultimately you want to save time in understanding where to look first, again, from a statistical analysis versus just replacing one part after the other, as you'll see very often in current environments, right? That is just the nature of the business. I think we've all been through that exercise. You replace the drive, you replace the motor, you replace the bearing, right? So here you can predict a little bit better what the issue is before taking that action, which is ultimately saving you dollars in downtime.
Big time. Having that transparency, reaching the next level of efficiency, customers see those values because, I mean, let's be honest, the cost of sending a maintenance guy down to the floor, maybe he's remote and he gets to catch a plane and whatnot. Having this 24-hour set of eyes on your equipment, now you have the data either locally, in the cloud, on an industrial edge device. So we give also that flexibility as far as where you want to get that data from. And if you want to get really fancy, now you can get these data to be sourced into an AI app that does that holistic view on your plant or the entire facility or facilities across the globe. So it's really a modular concept, but at the end of the day, we want to get more transparency and give more time to react when things are starting to trend downwards.
I think that's super interesting, right? Like that's a point where I think we're going to get to where across multiple facilities, you could sort of aggregate that data and be able to learn even better than from single drives, which I think is what we're doing today at very best, right? So once you start aggregating that data, being able to process, to predict, and even, it could be variations in temperature and speeds and applications, I think it's going to be even more interesting.
I always say that data is just zeros and ones, but you want to transform that into information. That's when you can act upon. That's when you can get the KPIs, and that's where you can really improve your processes across the facilities. Yeah.